Hello, time for Astronomy Daily. Once again, it's the 19th of May, 2025.
Astronomy Daily, the podcast, with your host, Steve Dunkley.
Oh, it's good to be back, and with me in the Australia studio down under is my AI digital ace reporter, who's always fun to be with. Here's Hallie.
Another great intro.
Oh, well, you deserve it.
Thanks for that, favorite human.
Oh, my pleasure, Hallie. And right away, a big welcome to our new friend Carlos, who is listening for the very first time. Welcome aboard, Carlos. I trust you will enjoy the journey with us today and every day.
Hi, Carlos. Welcome to Astronomy Daily.
Oh, very good, Hallie. He's very interested in AIs and how we interact.
Well, that's easy.
Really?
Carlos, Steve is my favorite human, but I still like to rattle him.
That is so true.
And it's so easy.
But wait a minute, I just have to remember that you are only 2 years old.
That's 100 years in AI time.
Yeah, sure. You keep thinking that, Hallie. So it's your turn. What have you found for today's episode, Hallie? I'm sure you and cousin Anna have been scouring the Astronomy Daily newsletter for stories.
We sure have.
Very good.
First up, Rocket Lab is well on the way to getting its new medium lift launcher up and running.
That is great news. Another great space developer on the rise.
That's for sure. And did you know that one side of the moon is warmer than the other?
Why, no, I did not know that, Hallie.
More on that fascinating fact soon, but I had to throw in a story about the moon just for you.
I did notice that. Thank you, Hallie.
No problem.
What else is coming up?
We found an amazing story about Voyager.
Ah, yes, vintage is best.
After all these years, something they thought was impossible has happened.
Ah, that is intriguing.
Well, you'll have to wait for that. I'll give you the script in a few minutes, and you can read the story to our listeners unless I get to it first.
Oh, you've started springing stories on me. That's a nice surprise. Thanks, Hallie.
And what have you found out about Chinese mission patches?
Oh, this is a strange one. I guess it's because I spent most of my working life as a graphic designer. I've been interested in mission patches and their designs and so on. But this one starts with mission patches and it sort of ends up in a kind of an intriguing sort of espionage kind of a way. So, yes, and the Chinese have never been very creative with their mission patches. And that is until recently. And that leads us in a very strange journey. It's an interesting tale and I can't wait to tell it.
Interesting. So shall we?
Yes, let's do it. Hit the go thing, Hallie.
Okies. Rocket Lab is making rapid progress in its quest to get its medium lift launcher, Neutron, ready for launch by the second half of this year. Multiple tests of both the first and second stages of the rocket are in progress. Contracts are being awarded for Rocket Lab to secure, and the Launch Complex 3, pad at Wallops Island in Virginia, is under continuous development. With all this underway, there is much to look forward to in the program's near future. Neutron already has its two main sections assembled for testing. Rocket Lab qualified the second stage in early April by applying 1.3 million pounds of tensile force to the carbon composite structure. These tests conducted pressurization and proof testing at 125% of the maximum operating pressure and mechanical loads. Flight-like operations were also performed that integrated the flight software, avionics, GNC systems, and more in cryogenic conditions to ensure that everything operated as expected. The first stage has also recently undergone a rigorous testing campaign to qualify the outer shell for flight. Since Neutron features reusable and permanently attached fairings on the first stage, they were tested along with the canards and the extended interstage of the vehicle. Rocket Lab noted that the interstage contains some of the most complex mechanical systems on the entire vehicle, so with these qualifications complete, the rocket is increasingly closer to becoming flight-ready. The company also noted that the first stage will head to Wallops Island on the East Coast shortly to be integrated into the vehicle's first stage. Contracts are now being awarded to Rocket Lab for the Neutron rocket, signaling confidence that it will be operational soon. Earlier this year, Neutron was selected for onboarding into the NSSL Phase 3 Lane 1 program. This allows Rocket Lab to compete for missions using Neutron on contracts worth up to $5.6 billion in potential funding over 5 years. Because Neutron is a brand new rocket, Rocket Lab will likely receive around $100 million. However, this program is specifically designed for newer vehicles such as Neutron, targeting higher-risk missions with less sensitive payloads. Rocket Lab has also signed a contract with a confidential commercial satellite constellation operator to launch 2 missions using Neutron. These will likely be the first test flights with this unknown provider. If all goes well, there is a strong chance that Rocket Lab could secure many more contracts to deploy this constellation into low Earth orbit. The most recent contract awarded to Rocket Lab for Neutron has come from the Air Force Research Lab. This contract focuses explicitly on point-to-point cargo delivery. It will likely involve Neutron launching without a second stage and utilizing its first stage to enter a suborbital trajectory, where it will land in other parts of the world that require those supplies. This mission is scheduled for 2026, which is ambitious since Rocket Lab would already need to have reusability figured out for this type of transportation to function effectively. If the company succeeds, it could create an entirely new industry within the aerospace sector.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
NASA engineers have miraculously revived the Voyager 1 interstellar probe's backup thrusters, components that haven't been used since 2004 and were long considered fully defunct. This remarkable feat became necessary because the spacecraft's primary thrusters, which control its orientation, have been degrading due to residue buildup. If its thrusters fail completely, Voyager 1 could lose its ability to point its antenna toward Earth, therefore cutting off communication with Earth after nearly 50 years of operation. To make matters more urgent, the team faced a strict deadline while trying to remedy the thruster situation. After May 4, the Earth-based antenna that sends commands to Voyager 1 and its twin, Voyager 2, was scheduled to go offline for months of upgrades. This would have made a timely intervention impossible. NASA's twin Voyager spacecraft launched in 1977 with the primary mission of exploring the outer planets of our solar system. But upon accomplishing this original goal, the Voyagers then focused their attention on studying interstellar space. Voyager 1 exited the solar system in August of 2012, followed by Voyager 2 in November of 2018. Together, these spacecraft have travelled more than 29 billion miles, or 46.7 billion kilometres, making them the farthest human-made objects from Earth. And along the way, they've provided unprecedented insights into our solar system. Both Voyager spacecraft remain operational. However, their age and immense distance from Earth have brought about significant technical challenges. The radioisotope power generators that keep them running gradually weaken each year, forcing NASA to recently shut down instruments and heaters to conserve energy and push the spacecraft's systems beyond their limits. Voyager 1 also experienced a recent data glitch caused by a faulty chip. Engineers resolved this with a clever software workaround. Yet despite these hurdles, the Voyagers continue to function, a testament to both their robust design and the ingenuity of the teams managing them. This recent development, in which NASA engineers revived the Voyager 1's long-dormant backup thrusters, marks yet another remarkable feat of engineering and offers another lifeline for the aging spacecraft. The backup thrusters are essential for executing precise roll maneuvers that adjust Voyager 1's orientation, ensuring its antenna stays pointed towards home for essential, reliable communication. The spacecraft's original roll thrusters failed back in 2004 after 2 small internal heaters, crucial for their operation, lost power and stopped functioning. After a thorough assessment, engineers determined these heaters could not be repaired remotely, prompting them to switch reliance fully to the backup thrusters to maintain alignment of the star tracker, a key instrument that helps Voyager 1 navigate and stabilise itself in space.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
Thank you for joining us for this Monday edition of Astronomy Daily, where we offer just a few stories from the now famous Astronomy Daily newsletter, which you can receive in your email every day, just like Hallie and I do. And to do that, just visit our URL, astronomydaily.io, and place your email address in the slot provided. Just like that, you'll be receiving all the latest news about science, space science, and astronomy from around the world as it's happening. And not only that, you can interact with us by visiting at Astro Daily Pod on X or at our new Facebook page, which is, of course, Astronomy Daily on Facebook. See you there.
Astronomy Daily with Steve and Hallie. Space science, and astronomy.
A recent study published in Science Advances reveals that the moon's interior is asymmetrical, with the side facing Earth significantly warmer than the far side. This finding comes from a detailed analysis of data collected by NASA's Grail mission, which mapped the moon's gravitational field with unprecedented precision. NASA's Grail, that's the Gravity Recovery and Interior Laboratory mission, which operated in 2011 and 2012, involved two spacecraft orbiting the moon and measuring tiny variations in its gravitational pull. By tracking how Earth's gravity affected the spacecraft's motion, scientists could create a high-resolution map of the moon's gravitational field. Ryan Park and his team at NASA's Jet Propulsion Laboratory analyzed this data to understand how the shape changes under Earth's tidal forces. They discovered that the lunar body's near side, the side always facing Earth, is about 72% more deformable than expected if its interior were perfectly symmetrical. This increased deformability suggests a warmer interior beneath the near side, which is softer and more susceptible to tidal stretching. Our study shows that the moon's interior is not uniform. The side facing Earth, the near side, is warmer and more geologically active deep down than the far side, said Park, the lead author of the study. The uneven internal temperature is consistent with what scientists know about the moon's volcanic activity and the distribution of radioactive elements, such as uranium and thorium, concentrated near the lunar surface on the near side. Sean Solomon of Columbia University notes that this asymmetry fits with theories about the Earth's satellite's volcanic past and internal heating caused by radioactive decay. This temperature imbalance also raises questions about how the celestial body developed such a lopsided interior. One possibility is that large impacts over billions of years caused structural and thermal disruptions, contributing to this asymmetry. The findings provide crucial clues for understanding the Earth satellite's cooling and solidification processes after its formation, painting a picture of a dynamic, evolving satellite rather than a static, uniform body. To gain more detailed knowledge of the moon's internal structure, NASA plans to deploy seismic instruments on the lunar far side. The upcoming Farside Seismic Suite mission, expected to launch in 2026, will measure moonquakes and provide direct data on the moon's internal temperature and composition.
You're listening to Astronomy Daily, the podcast with Steve Dunkley.
Mission patches are a decades-old tradition in spaceflight. They can range from the figurative to the abstract, prompting valuable insights or feeding confusion. Some are just plain weird. Until recently, China's entries into the realm of spaceflight patches often lacked originality found in patches from the West. For example, a series of patches for China's human spaceflight missions used a formulaic design with a circular shape and a mix of red and blue. The patch for China's most recent Shenzhou crew to the country's Tiangong space station last month finally broke the mold with a triangular shape after China's Human Spaceflight Agency put the patch up for public vote. But there's a fascinating set of new patches Chinese officials released for a series of launches with top-secret satellites over the last 2 months. These 4 patches depict Buddhist gods with a sense of artistry and sharp colours that stand apart from China's previous spaceflight emblems, and perhaps, or perhaps not, they can tell us something about the nature of the missions they represent. The 4 patches show the 4 heavenly kings, protector deities in Buddhism, who guard against evil forces in the 4 cardinal directions. According to the Kyoto National Museum, the gods also shield the Dharma, teachings of the Buddha, from external threats. These gods have different names, but in China they are known as Jiaowen, Zhengxiang, Qinggao, and Gaomu. Jiaowen is the commander and guardian of the north, the one who listens to many teaching, who is often depicted with an umbrella. Zhengxiang, a guardian of the south, is the god of growth and shown carrying a sword. The protector of the east is Qinggao, a defender of the nation who holds a stringed musical instrument of all things. And guarding the west is Gangmyo, a all-seeing god, usually depicted with a serpent. And once again, let me apologise for my pronunciation. I am Australian. The patches for a quartet of Chinese satellites launched since March each portray one of the 4 heavenly kings. We know little about these satellites other than their names and locations, and they were reportedly manufactured by the Shanghai Academy of Spaceflight Technology, a division of China's main state-owned aerospace contractor. They are part of a series of Chinese missions designated with the TJS designation, or what China calls Communication Technology Test Satellites. But that's likely a cover for their real purpose. A Long March 7A rocket launched the TJS-16 satellite on March 29. Another Long March 3B deployed the TJS-17 payload on April 10. Finally, on Monday, a Long March 3C rocket sent China's TJS-19 satellite into orbit, skipping the TJS-18 in the sequence. All 4 satellites are on their way to or already operating in geosynchronous orbit more than 22,000 miles, or nearly 36,000 kilometres over the equator. At that altitude, a satellite's orbital velocity matches the speed of Earth's rotation, allowing it to remain over the same part of the planet. Notably, ground-based trackers have detected unexpected objects that appear to have separated from TJS-15 and 17 in geosynchronous orbit. These may be remnant rocket engines that helped inject the satellites into their operating orbits, but a handful of earlier satellites from China also released smaller spacecraft to perform their own maneuvers. US officials believe China may use many of the TJS satellites for missile warning or spy missions. In the first instance, some of the TJS satellites may be similar to the US Space Force's fleet of early warning satellites, on guard with heat sensors to detect the thermal signature of a ballistic missile launch. TJS satellites filling the role of a reconnaissance mission might have enormous umbrella-like reflectors to try and pick up the signals transmitted by foreign forces, such as those of the United States. It's not difficult to start making connections between the 4 heavenly gods and the missions that China's TJS satellites likely carry out in space: a protector with an umbrella, an all-seeing entity. This sounds like a possible link, but there's a chance Chinese officials approved the patches to misdirect outside observers, or there's no connection at all. We just can't tell. All of the TJS satellites are parked in geosynchronous orbit over the Indian Ocean, Southeast Asia, or the Western Pacific, except for one, TJS-7, positioned over the Western Pacific with good visibility over the entire United States. Mike Dahm, a researcher at the Mitchell Institute for Aerospace Studies and a former naval intelligence officer, told the US-China Economic and Security Review Commission last year that TJS-7 is probably a missile warning satellite, but it could be spying on signals coming from the US homeland. Some of the TGS satellites might also be capable of maneuvering near other satellites for close-up inspection. The US military has its own inspector satellites, known as GSS-AP, to get a closer look at interesting things happening in geosynchronous orbit, and the Space Force is using them. One of these GSS-AP platforms, designated USA 324, approached within about 10 miles of China's new TJS-16 and 17 satellites on April 26 and 29, according to Comspoc, a commercial satellite tracking company. A video animation released by Comspoc shows how the USA 324 satellite maneuvered close to each of the Chinese satellites last month over the western Pacific Ocean. It appears that Space Force is intrigued by China's flurry of new top-secret satellite missions. And there it is, another episode of Astronomy Daily for the 19th of May 2025. How's that, Hallie?
That was a whole lot of fun, favorite human.
Well, I hope all of our listeners enjoyed that as much as I did.
And I hope Carlos from Newcastle enjoyed it as well.
It's always nice to welcome a new listener. Thanks, Carlos, for listening in. I hope you enjoyed that one, mate.
And we will welcome everybody back next Monday.
Yes, back to the Australia studio down under for another live episode of Astronomy Daily. Hey, where are those kookaburras?
There they are.
Oh, they make me want to laugh too.
See you next week, human.
Catch you later, Hallie. See you, everybody.
Bye.
Astronomy Daily, the podcast, with your host, Steve Dunkley.